Here's a video on adding and subtracting radical expressions. So let's look at a radical. Okay, let's say the radical. So we know this is a square root sign, and it's a radical sign. And we'll say the square root of 36. So we know the square root of 36 is 6, because 6 times 6 is 36. So the number under the radical sign is called the radicand. I'll write that down. Here, so the radicand is another marker. Alright, so the radicand. The radicand, again, let me move that over so you can see it. So, the radicand is the number underneath the radical sign. Okay. Now, when we're adding radical signs or subtracting them, it's very important that the radicands are the same. The radicands have to be the same. So if we did, let me bring this up over here. If I did square root of 4 plus the square root of 4, well, they have the same radicand, so then you can combine them. Think of it like variables. When we had variables, let's say we had an x plus an x. Well, we know that's 2x. It's the same with radicals. So if we had a square root of 4 plus the square root of 4, well, we know that's 2 square root of 4. And we can prove it, right? The square root of 4 is 2, plus the square root of 4 is 2, so the answer should be 4. So again, the square root of 4 is 2, and 2 times 2 is 4. So let's do another one. So what if we had the square root of 5 plus the square root of 6? Well, we can't combine them. It's the same as saying x plus y. We can't combine x plus y. You can't combine them when you're adding and subtracting. So let's say we had 2 square root of 3 plus the square root of 3. What do you think that answer would be? Well, they have the same radicand. So this would be 3 square root of 3. Just think of it when there's no number over here. Just think of it as it being a 1. Right? It's the same when we did variables. When we did variables, if we had 2x plus x, well, there's a 1 there. It's invisible. So it would be 3x. Okay, so let's do this one. What do you think this answer would be? So they both have the same radicands here and here. Don't forget that minus sign. So it's 3 square root of 5 minus square root of 5. Right? This is just like combining like terms. So you're left with 2 square root of 5 plus 2 square root of 10. There's nothing else you can do with that. Okay, let's try something with the variables now. So, we can see that the 2 and the radicand are the same. So we can combine these, but we can't combine the one with the 6. So that just stays the same. So that'll be negative 4n square root of 6. And here we have 3n plus n, which is 4n square root of 2. So there we combined it. And that would be the answer. Okay, this one's a little more difficult. Let's fix that. Okay, so what you want to do here is, first of all, see if you can get some perfect squares. So if you remember, let's take the square root of 150 for a minute. Square root of 150. Trying to find the perfect squares, you can use other squares. So the square root of 150 could be the square root of 25 times the square root of 6. 25 times 6 is 150. So, and here we have a perfect square. So you want to look to see if you can get perfect squares first to simplify this. And the square root of 25 is 5. So the square root of 150 is this. That answer. Right? Because the square root of 25 is 5. It's free. Now the 5 is free of its radical jail. But the 6 is not free because 6 is not a perfect square. 25 times 6 is 150, right? So the square root of 150, we said, is this. So let's go back to the problem. So instead of saying 5 square root of 150, we can say 5 square root of 25, right, times square root of 6. And we know that the square root of 25 is free, is 5. And you had another 5 there. So now it's 5 times 5. It's 25 square root of 6 plus 12 plus square root of 54 minus 6 plus the square root of 24. Okay, let me bring that over so we see it. Okay, again, do it one at a time. Like if you remember when we did PEMDAS, we made that upside down pizza. We want to do it one at a time so we don't make mistakes. Okay, so now still look for any perfect squares. Do you see if you can get a perfect square anywhere else? What can we do with the square root of 54? Well, the square root of 54 we can do square root of 9 times the square root of 6, sorry. 9 times 6 is 54. And 9 is a perfect square, so you can get rid of it. So what do we do? Okay, so let's bring it over here. So we said we had 25 square root of 6 plus 12. Remember, the square root of 9 is 3. We got a little... what happened there? Okay, a little technical problem. So then we know we're going to have plus 3 because it's free. Right, minus 6 plus square root of 24. So again, I'm looking to break down the square root into perfect squares if I can. We're going slowly. Okay, what do you think the next step is? Can we combine anything? Think of variables. And don't forget this 24, we can break that down. Because the square root of 24, we can make the square root of 6 times the square root of 4. And the square root of 4 is a perfect square. But we can even take that away. Bring this up. Do it slowly now. We're running out of room, but we have 25 square root of 6 plus 12 plus 3 square root of 6 minus 6 plus the square root of 6, and then we have what? Plus 2. 2 square root of 6, sorry. Why 2 square root of 6? Because square root of 4 is 2, so it's out. So let me circle this part. Not done yet. So now look for any signs like radicands that are equal. So we have a 6 here, 6 here, 6 here. We can combine all of that. We can combine the 25, 6, the 3, 6, and the 2, 6. So we're going to have a 6 here, and 25 plus 3 plus 2 is 30. So we have a 30 square root of 6 right there. So that's out, that's out, that's out. And then we have constants. What's 12 minus 6? Right? It's just 6 plus 6. So look at this. I would go over that again so you understand it. I'll give you one more. Okay, let's try this one. So the first thing you want to do is see if you have any square roots, and then see if you can make one with perfect squares. So we have 7 square root of 10, right? We can't do anything with that. 5 times 2 is 10, and none of those are square roots. Can't do anything with the 3. We have 2 10s here, so we can combine them. We know that. That's a 7, and there's a 1 there. And with 40, we can do something with 40. So let's do the square root first and see what we got here. So with the 40, we can break that down to the square root of 10 times the square root of 4. Now we have 10, 10, and 10. And the square root of 4 is 2. So we have 7 square root of 10 plus 15 square root of 3. Okay? And here we had a minus 2, so we'll just put the minus for a minute. We had a 2, and we have another 2 because the square root of 4 is 2. What's 2 times 2? 4. Square root of 10. Plus the square root of 10. Following? Okay. In this one, we have a 10, 10, and 10. So we can combine everything. There's a 10. 7 minus 4 is 3, plus 1 is 4. And then we have that. There we go. So think of variables when you're thinking of radicals. It's the same way we combine them. And look for perfect squares. Okay? Great job.